Okay. And today's lecture we are going to uh, basically this is a continuation of one topic that we studied before midterm also. That let me go into the whiteboard. That if you have one beam, for example, this beam, and you want to find and there is a moving load or a set of moving load, for example 20 kilonewton or 10 kilonewton, and you want to find maximum shear force at, let's suppose, this point P due to this moving load, then what was our approach or what was our method? We already discussed this method before midterm also, so I will briefly revise it. That our approach was, if this is our beam and I want to plot or I want to find maximum shear force at point P, what did I do? I will plot the influence line diagram for shear force at this point. Let's suppose that the influence line diagram is something like this one, and now I have the influence line diagram, and then we used to move this set of load. For example, if this distance is 2 meter on this beam, firstly, let's say I would place this unit load over at this point, let's suppose, and I will calculate the shear force. And how will I do that? I will multiply this load by these ordinates that are exactly under this point. And let's say this ordinate was 2, this was 1. So I would multiply these moving loads with these ordinates of the influence line diagram. And finally, I will get the shear force. Let's suppose this value is 50 kilonewton. So what does this value shows? This value basically represents then when my unit loads are at this location, then shear force at this particular point P is 50 kilonewton. And similarly, if we want to find the maximum shear force at point P, we will do different trials. We will place the unit load, let's say, firstly at this point, then maybe at this point, and then we will keep on getting the values of shear force at point P, and from those values, we will select the maximum one. And there is another thing that we didn't discuss in that lecture was, what if UDL is acting on this, or what if there is a moving UDL? Let's say this is a UDL of 10 kilonewton per meter. So in this case also the approach is same, but there is a slight difference that in the case of point load we have to multiply it with the ordinate. But in the case of UDL, let's say this UDL is of 5 meter, we will place this UDL at different locations on this beam. And if this is the diagram for shear force, and for example I have placed this over here at this length of 5 meter, and in the case of UDL, I have to multiply the magnitude or the value of UDL with the area of this influence line, which is lying directly underneath this length. For example, if the UDL is over this length, I would multiply this UDL with this area of triangle, let's say it's 10 into 1, and I will get one value. And this value is my shear force. And why we are doing, or why we are multiplying it with the area and not with the ordinate? Because actually it's the same thing. In the UDL, for example, the UDL is acting over the entire length, and you have to multiply with each ordinate separately. So that is a bit hectic task, because you can't find out like infinite number of ordinates. So what you do, you calculate the area, which basically represent the variation of shear force on this length, and you multiply this area with this component or this value of UDL, and you will get the shear force value. And similarly, you will keep on doing the trials. You can place the UDL over this length, multiply by this one area, and then finally you will get one answer, which is the maximum shear force. So this is how you approach the questions for the UDL, or when there are set of moving loads which are acting on a beam and you want to find the maximum value of any function. And this is true for all three cases, for shear force, for bending moment, and for the reaction as well. Even if I want to find the maximum bending moment in this beam, I will multiply this magnitude of UDL with this triangular area, and I will get the bending moment. So, and you have to keep one thing in mind, that in these questions we are finding the maximum influence or the maximum value of a function at a particular point, maximum value of function at one point. For example, let's say in this case, we are finding or calculating the value at point P. So this is one point in the beam, and it is quite possible that this maximum value may be less than the maximum value for the entire beam. For example, let's say there may be a point Q over here on which the maximum value of bending moment is even, or shear force is even greater than this 50 kilonewton, maybe 100 kilonewton. So this maximum value is for one point and not for the whole beam. In the next class, we will be calculating the maximum value of function for the whole beam case. So there is a difference between the two. For now we are focusing on one point, and in the next class we will be focusing on the whole beam, that where is or at which point maximum bending moment or maximum shear force or maximum reaction would exist in a beam. So any confusion about this one? Let's solve one example to understand this concept better. For example, this is a beam, and I want to calculate the maximum shear force at point P. And these are my two moving loads. One is the UDL of 5 kilonewton per meter, and the length of UDL is 7 meter. Okay, and another one is this point load of 30 kilonewton. So our first step is, and I have to find the maximum shear force at point P. So our first step is the same, that I have to plot the influence line for this beam. I'm not going to do that again because we also did this, plotted the influence line in the lecture before Eid holidays, so you can see from that also. So the final result or the final influence line for this beam was something like this one. This is my point P. So this was the ILD for shear force at point P. This ordinate was 0.5. This is point, let's say this is A point and this is B point. So this is point A, this is point B, and this is the free end. This distance is 2 meter, this distance is 3 meter, this is 1 meter, this height is 0.25, 0.75, and 0.5. So now we have the shape of ILD, and we have two loads or two moving loads. One is the point load and the other is the live load, live UDL, let's say. So first we obviously we have to do trials and look at different locations to see that, and to calculate the shear force at different location, and then we can decide that what is the maximum value of shear force. So let's say in the trial 1, I will place the 30 kilonewton unit load at this point P, and I will place this UDL over entire length. But you have to remember one thing, this UDL is of 7 meter only. So even if I place it on entire length, my beam is of 3, 4, 5, 6, and 8 meters. So 1 meter will still be free. Let me show you this on the beam. So this is my beam with a hinge and a roller support, and this UDL is of, this length is 2 meter, 3 meter, point P, this is 1 meter, and this is 2 meter. Okay, so this is my UDL of 5 kilonewton per meter on 7 meter distance, 2, 3, 4, 5, 6, and 1 meter on this side. And I have taken 30 kilonewton at point P. Class, are you getting my points? So I have placed this unit load of 30 kilonewton at point P and
Sir?
this yes.
सर ये जो 30 किलो न्यूटन हम प्लेस कर रहे हैं पॉइंट बी पे, ये गिवन है हमें?
What? I didn't get you.
सर ये गिवन होगा, ये जो 30 किलो न्यूटन आप
No,
प्लेस
no,
कर रहे हैं पॉइंट बी पे?
it is just a trial. You have to find the maximum value of shear force. So it's not given. You have to figure it out from the influence line diagram. For example, wait a second. This was my influence line diagram, right? So from the influence line diagram, I have seen that there is a point 0.25 and 0.7, and this is 0.5, and this is 0.5. So from this influence line diagram, I will figure out that at what point should I place this 30 kilonewton load that I will get the maximum value of shear force, and at what location I will place this UDL to get the maximum value. So for the trial one, I have placed it over point P. I think for this one, we may not get the maximum value because maximum value should be over here. So we will do it in the trial two. So in the trial one, we have placed it over here and we will multiply it with these ordinates and multiply the UDL with the area of triangle, and let's see what value we get for the shear force. So it's not given, it's basically a trial and error procedure. So I placed this point load at this point and UDL at this point. So what will be my shear force at point P? Anyone can give me this answer? So I will multiply this 30 with this component 0.25. And the second one is this UDL. I have to multiply this UDL with the area of this triangle. So I will divide this whole triangle or this whole ILD shape into small triangles so I can calculate the area. So firstly, it is acting on this 1 meter distance. What is this ordinate at 1 meter? Anyone? Usman? What is this ordinate? Khizar?
Yes, sir.
What is this ordinate?
Sir, sir, I have no idea.
Zan? Are you sure you don't have any idea? Can't you calculate it?
Sir, 0.25.
Sir, 0.25.
Yes, just solve the simple triangles or similar triangles. So for the point load, I will multiply it with this coordinate, and for the UDL, I have to multiply with the areas of this triangle. My UDL is 5 kilonewton, so let's say 5 into, what is this area first? Half into 0.25 into 1, okay? And for this triangle, what will be my area? Plus half into 0.75, and this length is 3 meter, so this is 3. And for this triangle, again I have length of, but there is one thing that you have to notice, that this triangle is on the negative side, so I have to put the negative sign on this side. And similarly for this triangle, I have half into 0.25 into 1. And for this fourth triangle, this is also on the negative side. So minus half into 0.5 into, the distance is 2 meter. So it is 2. So what is my shear force at point P? Anyone? Do you have calculators with you? Varun, Naveed,
Yes, sir.
what is the shear force at point P?
Sir, I'm just calculating it. मैं अभी लाया हूँ.
Can you do it
एक मिनट
quickly?
बस मैं वही calculate कर रहा हूँ. Yes, sir, just give me a minute.
And I think those who are not answering, I should not be marking them present. Maybe they are not even listening to the lecture.
सर माइक खराब हो जाता है कई बार मेरे खुद ईयरफोन का पिछले वीक माइक खराब हो गया था.
Are you using your laptop?
यस सर. यस सर.
So I think it should
Sir,
work.
4.3 कुछ.
Can you check it again?
Sir, actually I don't have my calculator with me, so like I'm.
Sir, 0.625.
Yes. So the shear force at point P is 0.625 kilonewton. So let's do another trial. Because now you have seen that for this case of UDL, obviously I have multiplied with the areas, but these two areas are subtracted from this one. So maybe this is one of the reasons that you are not getting a maximum value. What if you place a UDL, because this is a live load, by live, yes.
At point B, why we not multiply with 0.75?
Actually, we didn't do it because, like I told you, that there is a point just before this point P on which 0.25 is acting, and there is a point just next to this point P on which 0.75 is acting. So you can do a double trial. You can do it also for 0.75, but in that case, you will have 30 into minus 0.75 because this 0.75 is on the negative side. So in this case, you will get even lesser answer than this one because this will also be subtracted. Did you get my point?
Yes, sir. Please.
So this is why
Sir,
we did for
30 kilonewtons UDL के मिड पे ऐड करें या हम इसको डिफरेंट मतलब इसको
No.
भी अलग हम वेरी कर सकते हैं.
No, this is a separate load. It's not acting anywhere. It's just like a UDL and a point load. So you have to consider separately both.
Okay.
Yeah. So in the case of UDL, you have seen that these two components are being subtracted from this, are multiplied with this 5 and get subtracted. So this can cause reduction of shear force. So what if this UDL I was talking about is a live load? By live load, I mean that this is a moving load and you can place it anywhere. Even you can place it something like this. For example, this is my beam and I can place it somewhere like this one. Like this part can be outside of the beam. So what does this mean? That it won't have any impact. So if I place it something like this one, that I multiply the maximum part of UDL with the positive components of ILD, I may get the maximum value of shear force at point P. So to verify this condition or situation, let's do another trial. In which I will place the point load at left hand and UDL will also start at left hand. So if I show you this on the beam, This is my beam. I have placed this 30 kilonewton over here. And let's say UDL is somewhere over here. 2 meter, 2 meter. And this 3 meter portion of UDL is outside my beam. Okay. And this is my point P. This distance is 1 meter. This distance is also 1 meter. And this is 2 meter. So if I plot the shape of ILD again, this is 0.5 and this is 0.25, 0.75, and this is 2 meter, 1 meter. So what is this component at a distance of 2 meter? Fizzer, can you do it now?
Yes, sir. So just give me a minute, please.
Other students start calculating the value of shear force at this point P. And give me the answer.
Sir,
Yes.
location of 30 kilonewton is given.
No. I have assumed it, or I am doing the trials procedure. So I will place it at different location in combination with the UDL, and I will calculate the shear force at each point, at each location, and then I will see what is the maximum value.
Sir, it is 0.25.
Huh?
0.25.
0.25. Okay, this is 0.25. And what is the value of shear force at point P? I think this value is 0.5.
0.5 नहीं होनी चाहिए.
Yes.
0.5.
0.375.
What is 0.375? Yes.
0.375 आ रहा है.
This component?
Yes sir, ये 0.5 वाला जो है 1 meter distance पे.
This one, right? I think this is 0.5. So can you do it again?
Sir, it's 0.5.
Okay sir.
Yeah, because the whole length is 3 meter. For 3 meter you have 0.75. So for 2 meter you will have obviously 0.5. So what is the shear force at point P? Let's say for this 30 kilonewton, it will be multiplied by this component, that is 0.5. And this UDL will be multiplied by the area of these two triangles. 5 kilonewton, which is UDL. And the area of this triangle is half cross 2 cross 0.5 minus half multiplied by 0.5 multiplied by 2 meters. So what is this answer for shear force?
15.
15. Okay. So for the trial 2, I have got the answer as 15. But in this one, you can also see that still there is a negative component. And we can visually look at this beam, and maybe there is a case that we completely eliminate this negative component and find such a location for this live UDL that we will have only positive triangles. So this is only possible in one case that I placed. So now let's say in trial 3, I will place this UDL in such a way that only 2 meter length is acting inside the beam and 4 meter is out or 5 meter is outside the beam. So 2 meter length is only inside the beam. So for this trial 3, what will be my value of shear force? This 30 kilonewton is at same location. So let's write quickly the equation for shear force at point P. This 30 kilonewton will again be multiplied with this 0.5, and this UDL will be multiplied by the area of triangle, that is half into 0.5 times 2. So what is the value of shear force now?
$17.5.
Can anyone else confirm this? Because I don't have this value.
Yes, sir, 17.5.
Okay. So 17.5. Now you can see that when only a small portion of UDL is acting on the beam, we are getting the maximum value of shear force at point P. So the thumb rule or the method or the approach that you can adopt is to look into the beam visually and decide that where should I place my UDL that I will get the maximum value from this component, because for point load it's easy to figure that out. For example, if I will place the point load at this location, I am going to get the maximum value because this is the maximum ordinate. I can place it over here, but in this case I will get the negative value because this 0.75 is on the negative side and both of these will be subtracted. So this is how you can get the maximum value of any function, be it the reaction, shear force, and bending moment when 2 or 3 different kind of loads are acting on a beam. So if there is any question about this one.
Sir, yeah, in the second and third trial, what is the difference in the position of the UDL? Can you please explain that concept?
In the second trial, I have placed 4 meter length of my UDL because the total length of the UDL was 7 meter. So in the second trial, I have placed 4 meter on the beam. But in the third trial, I have placed only 2 meter on the beam. 5 meter is outside the beam because it is obviously a moving load. So it can be placed. For example, let's suppose this is a truck. So there is a time when it is moving over a bridge or any kind of a structure that half of it is already gone or 5 meter of it is already outside the structure and 2 meter is on the beam. So when its location is somewhat like this one, then you are getting the maximum value of shear force at this point P. Okay. So is there any other question?
सर ये पॉइंट पी पे कैसे है? मतलब हम ये क्यों कह रहे हैं कि ये पॉइंट पी पे है? मतलब ये shear force.
Actually, what does ILD give you? Or what does this ILD or influence line diagram represents? It basically represents the variation of any function. By function, I mean shear force, bending moment, or reaction. In this case, it is for shear force. It represents the variation of shear force when my unit load is moving at different on this beam at this point P. So I will place or I will move the unit load over the entire length, and I will compute the shear force at this point P, and I will plot this. So for example, this ordinate is my value of shear force at this point P when my UD or when my unit load was at this end. Similarly, this is the value of shear force at this point P when my unit load was at this point. So when I multiply it, or when I multiply this applied or external moving loads with these ordinates, obviously I am going to get the value of shear force at point P, because ILD is for every point separately. Did you get my point?
Yes, sir.
So let us do another question similar to this one. This is the question that there is a beam which is supporting a uniform dead load of 0.4 kPa and a live load of 1.5 kPa and a single live concentrated force of 8 kPa. So by concentrated force, obviously it means the point load, and we have to determine the maximum positive moment at point C and the maximum positive vertical reaction at point B. And in the question, it's given that the A is a roller sport and B is a pin. So let me plot it over here. So this is the beam, and at A there is a hinge support, and at B we have a roller support. This is point C. This distance is given as 10 feet, 10 feet, and 15 feet. And I have to get the maximum value of moment at point C. First part is this one. And the second one is maximum reaction at support A, I believe. Let me check it. At B. Okay, yeah. At this left support, I can call it as A. At this support A, and the loads that are given in the question are dead load of 0.4 K per foot, live load of 1.5 kips per foot, and point load of 8 kips. So by dead load, we have studied this before as well. Dead load is basically the loads which are not moving or which are placed on the beam or a structure for its whole life. Usually the dead load is basically the load of the beam itself, because other than that all the loads are movable. Even if you see in a common house or in this case or in our case, the slabs, on the slabs all loads are the moving loads or which can move. So the dead load is basically the load of the structure itself. So let's say this dead load is acting over beam and it cannot move. So this 0.4 kip per foot will be acting on the entire length of the beam and it can't be moved, just like we did in the previous case for the live load. And similarly in this one, the live load can be moved, and we have to look at the influence line diagram to figure out that where should we place it to get the maximum value of moment. So first step is obviously to plot the ILD for movement at point C. You can do it by any method, by Muller principle, by tabulation method, or whichever method you feel is convenient for you. So the shape of ILD will be, for this one, is something like this. And this component is 5, and this component is 7.5. Okay. So in the first trial, or in this example, you can see that you can easily figure out that where should you place your loads that you can get the maximum value. So in the first trial, I will place my point load at this point C. Point load at C, let's say over here, of 8K, because at C point I have already the maximum component or maximum positive component, because we have to find, it was given in the question that you have to find your maximum positive moment. So maximum positive moment is at point C, that is 5. So I will place my point load at this point C, and I will place my live load of 1.5 K per foot on this length, let's say from A to B. Because if I place it over entire length, obviously this component will be subtracted and you are not going to get the maximum value. So let's say I have placed my point load between A to B and the value is 1.5. So what will be the moment at point C? That will be 8. Again, point load you have to multiply with this ordinate of 5. And for this live load, you have to multiply with this triangle, that is 10 feet and 10 feet. This is 15 feet. So 1.5 into half into 10, and this ordinate is 5. Okay. So one triangle is this one, and the other one is half into 10 into 5. Okay. And the third load is the dead load. The dead load is acting over the entire length and you can't change it because it is the weight of the structure itself. So it will remain as it is. And the value is 0.4. And now there are 3 triangles for this dead load case. 2 of them are this ones, half 10 into 5 plus half plus 10 into 5. And this one is on the negative side. So it will be subtracted. Minus half into 2 into 7.5. So can anyone give me the value of this moment at point C?
सर ये हाफ 15 into 7.5 नहीं होगा?
Yes.
Sir, is the answer 112.5?
112.5 get fit. So this is the maximum value, and in this case there is no other scenario in which we place these two loads that we are going to get the maximum value. So we don't have to do the don't have to do another trial. So in the second part of the question, we were supposed to calculate the maximum reaction at A support. So again, we have to follow the same steps. First, plot the ILD for this beam, for the reaction. For example, this beam, it's this one. And what will be my ILD? Obviously, I will place a roller guide if I plot it with by using Muller principle. So you can do it by any method. So the shape is something like this one. The ordinate is 1 over here and minus 0.75 over here. This length is 20 feet. And now again, in this one, I will do the trials. And since I have to get the maximum value, so again, this dead load will be acting over entire length. We can't change it. This live load will be acting over this length, because for this one, we are going to get the maximum value. And let's place the point load at directly on this support A. This is 8, the live load is 1.5, and this dead load is 0.4 K per feet. So to find out the reaction at A, I will again multiply with the ordinates. 8 into 1 plus 1.5 into half cross 20 cross 1 plus 0.4 half cross 20 cross 1 minus half cross 0.75 cross 15. So what is this reaction at A?
$24.75.
Yes. So this reaction, or the maximum value of reaction at A, what does this mean? That the maximum value of reaction at support A will be in the case when the dead load is acting over the entire length, the live load is acting in the portion between these two supports, and the point load is at directly above this support. So this basically concludes today's lecture, and we were supposed to solve these two questions. And if you have any question, you can ask me right now.
सर जो बेंडिंग मोमेंट के लिए हमने आईएलडी बनाई है, इसमें ऑर्डिनेट्स 0.5 और 0.75 नहीं होंगे?
For bending moment, I think it's 5. You can plot it again, because I did it and I got these two ordinates. But obviously you can plot it again to check it.
Okay.
Why it should be 0.5 or 0.75?
तो मुझे लगा कि हम वो पॉइंट लोड को
Yeah, it's
पॉइंट
for
लोड
the
की वजह से
we are doing it for the point load. So let me give you one question that this is your beam of 10 feet, 10 feet and 15 feet and plot the ILD for bending moment at point C. By the same method, you are going to get this this shape. We have to follow the same principle, place the point load at different location, or you can plot it by Muller's principle as well. Okay.
Okay.
So if you don't have any question, can I ask one question? That this ILD is for movement, right? So what we are doing is basically plotting the movements by placing the unit loads at different location. So for example, this 5 is one moment when my unit load was at this location. And the value of movement is usually kip fit, let's say, or kilonewton meter. So in this case, for example, let's take this component. What are its unit? This is 8 kips and this 5 is also in the units of moment. So this the final answer should be something 40 kip square feet. But I have written the answer in kip feet. Can anyone answer me why we are doing this or why we did this? Because it should be kip square feet. I was expecting you to ask this question, but no one asked this. So now, if someone can answer me this question, that why the final answer is in kip fit. Anyone?
So हमारी बेस लेंथ हम लोग फीट में इस्तेमाल करें, इसकी वजह से मल्टीप्लाई हो रहा है ऊपर से.
Base length is in feet. So what does that mean?
So the final answer will be in feet as well.
I didn't get it. Can you say it again?
सर आप दोबारा एक्सप्लेन करेंगे, आप what are you asking?
Actually, the question is that this ILD is representing the moment. For example, this 5 is one moment, this 7.5 is one moment, and
Yes,
this, let's say, every value is one moment. So I'm multiplying this 8 kip, my unit load, with this ordinate, or let's say with the moment basically, right?
Yes, sir.
This 5 is the moment. So the unit of moment is obviously something like kip feet or kilonewton meter or whatever is the case. So I'm multiplying one moment with the point load. So I should be basically getting the answer in kip square fit. But I am giving the answer in kip fit. Why is that? So I will leave it to you and try to think it, and maybe in the next class, some of you will come up with the answer. If not, then maybe I will try to answer it.
Yes, sir.
Try to think about it. Try to think that what we actually did in this ILD's case, and you will get the answer, I'm sure about this. So if there is another question, you can ask me now. And I want you to be attentive in the class. I have noticed that maybe some of you have muted your mics. So this is not a good way to go about it.